Okay, let's get started. So for the next few weeks, we're going to be taking a break from integration. So it can be quite a good break. So for the next couple chapters, polar coordinates, conic sections, sequences, and series, there won't be any integration. Okay. And then a bit later on, the integration is going to come back, but not as bad as we had it for semester one. Yeah. So please do not forget your integration techniques from semester one. We will be needing it later on, but not as much as semester one. But just keep that in mind for later on. This week, we've got a new chapter, polar coordinates and polar curves. So polar coordinates, you would have seen something like that before, probably in physics for rotations. You might have seen that. But we're going to start right from the beginning. So if you forgot it from physics, that's fine. We'll start from the beginning. And then the next part on polar curves, we're going to be drawing some nice pictures. So please make sure you have some colored pens with you. If you don't, that's fine as well. Just make sure you put down the labels that are right down. Okay. Right. So let's start with polar coordinates. What are they? How do we calculate with them? So everyone's familiar with Cartesian coordinates, so x and y. So let's say we have the following system here. Okay, x and y. So that is our usual Cartesian coordinate system for the plane. Now, any points in this plane, we can label by x and y. So how much along x is the point, how much along y is the point. Whatever those two values are, we call them x and y, and that is the coordinate. So let's say we have a point P over here. The distance along x and the distance along y gives us x, y for this coordinate. Yeah, that's the usual Cartesian, very simple. What we're going to do now is find a transformation from this coordinate system, Cartesian, to another coordinate system called polar coordinates. The way polar coordinates work is instead of using the distance x and y to label the point, we use the distance from the origin as one of the labels and the angle with the x-axis as the other part. Okay, so instead of x and y, we use r and theta. So r, that's the distance from the origin to the point, and theta, that's the angle that it makes with the horizontal. So we can fill that in here. So let's say we've got this line here, and we can draw in our right angle triangle. So from the points given, we know that the base of the triangle is x. The height of the triangle there, that's just going to be y. Okay, that's still in Cartesian. What we want to do is now convert to polar coordinates, where instead of x and y, we look at r and theta. So here, this is going to be r, and this angle here, theta. Okay, so it's just two different numbers for the same point. Now, the idea is, how do we go back and forth between the two? So it's the same point. If I give you x and y, how do you calculate r and theta? Or if I give you r and theta, how do you calculate x and y? Okay, we want to find the transformation between these coordinate systems. Okay, so we want to find the transformation between these coordinate systems. Okay. And you'll see this a whole lot next year in the Math 238 when you're doing integration in Cartesian coordinates and you want to transfer over to integration in polar coordinates, you use these transformations. Yeah. However, we're not going to do any of the integration. We're just looking at the coordinate transformation. Okay, but please do not forget this for next year. Okay, so let's go from Cartesian to polar, and then we'll go the other way around. So given x, y, so whatever the point is, in Cartesian coordinates, we want to find r and theta. Okay, again, just two labels for the points in polar coordinates. Okay, so we start with Cartesian and we end up in polar. Okay, that's very easy. We've got a right angle triangle. Going between them is just using Pythag and our trig ratios. Okay, so we're given x and y. We want to calculate r. That's just the hypotenuse. Okay, so the radius r is just root x squared plus y squared. Okay, normal Pythag. Yeah. What about theta? Well, we have the opposite side, y. We have the adjacent side, x. So what relates the two? Tan. Tan theta will be y over x. And if we just want theta, we don't want tan theta, we can do arctan or tan inverse. So given x and y, we can calculate r and theta like this. Now we can go the other way. Given r and theta, we can calculate x and y. And that allows us to go back and forth between the two. So number 2, given r and theta in polar coordinates, we want to find xy in Cartesian coordinates. Okay, so now we're doing the inverse. We're going back. So we have r and theta. We want x and y. So again, we look at our diagram. So we have r, we have theta. How can we find x? Cos, yeah. R cos theta will be x. And if we wanted y, sin theta, yeah, that will give us y. So given r and theta, we can calculate x as r cos theta and y as r sin theta. Yeah, very easy. And this allows us to go from polar to Cartesian. And in the first one, we're going from Cartesian to polar. So you can go back and forth between them. Let's have a look at some examples. Okay, so number 1, convert the following Cartesian coordinates to polar coordinates. Okay, so we're given a point in Cartesian form, x and y. We want to convert that point into polar form with r and theta. Okay, so number 1, 1, 0. Okay, so now we know that this is in Cartesian form. So the first entry must be x and the second entry must be y. Okay, so we know x and y. So we want r and theta. So what is r going to be? 1. Yeah. Okay, and what about theta? That's the angle from the x-axis to this point. So arctan y of x. 0. Yeah, the angle 0. Okay, so arctan of 0 is 0, so theta is 0. Number 2. Okay. Sorry, 2 comma 1. So we can read off the x and y. So x will be 2, y will be 1. Okay, and then given that, we want to use those formulas we wrote down to convert this from Cartesian, x and y, to polar, r and theta. So r, that's going to be root 5. And theta, 0.46. Please remember radians. Very easy. You just put in your calculator, you get your answer. So if there's decimals and stuff, 2 decimal places is fine. Okay, you know that. Okay, number 3, minus 1, 1. Again, we know that this is in Cartesian form. So we read off x and y. X is minus 1, y is 1. And now we want r and theta. So if x is minus 1 and y is 1, r will be root 2. Good. And theta, arctan of 1 over minus 1. Minus pi over 4. Good. And then just a little note about negative angles here. So if we have something like this, so x and y. So we see here this is a negative angle. What does that mean? So normally positive angles are going counterclockwise, right? From the x-axis. So when we measure angles, we go that way around. Okay, that will be the positive angle. If your angle ends up being negative, it just means you're going clockwise. So here, if we have this angle theta, we can go all the way around, okay? The counterclockwise, that will give us the positive angle, or we could go clockwise by the negative angle. We get the same thing. Yeah. So here, if this angle is minus pi over 4, then the full angle going counterclockwise, that will be minus pi over 4 plus 2 pi, right? Because all the way around is 2 pi. So you can either leave your answer as a negative angle going clockwise, or you can leave it as a positive angle going counterclockwise. That's up to you. I don't care. Okay. Any questions for these 3? Okay, very simple. So you're given x and y. You use the formulas to find r and theta. Now let's go the other way. So now given r and theta, we want x and y. Okay, so number 2. Convert the following polar coordinates to Cartesian coordinates. Okay, so 2.1, we have 3 and pi over 6. Yeah, so we can read off the information we need. So the first entry there, 3, that must be r, and the second entry, pi over 6, that must be the angle. Okay, so now we want to go back to x and y. So we've got r, we've got theta. How do we find x? R cos theta. We have r, we have theta. We can find x. So it will be 3 times. And then cos of pi over 6. Special angle. Someone said root 3 over 2. Yeah. Okay, and then y. We have r, we have theta. So y will be r sine theta. Sine of pi over 6. A half, yeah, special angle. Okay, so we have x is 3 root 3 over 2, and y is 3 over 2 in Cartesian form. Let's have a look at number 2. We have 1 and pi. So again, we can read off r and theta. So r, that will be the first number 1. And theta, that will be that second number pi. Okay, so we have r and theta. We want x and y. So x, that will be r cos theta. What is cos of pi? -1. Again, special angle. So this will be -1. And y, that will be r sine theta. Sine of pi? 0. Easy stuff. Okay, and then number 3. 2 and pi over 4. Okay, so again, we read off r. That's the first value. So that's going to be 2. Theta, that's the second value, pi over 4. And we can find x and y. So x, that will be r cos theta. What's cos pi over 4? It's another special angle. Yeah, 1 over root 2. So x, that will be 2 times 1 over root 2. 2 over root 2. And y, that will be r sine theta. So sine pi over 4. Okay. Sine pi over 4. Yep. Yeah, you can simplify it. You can times top and bottom by root 2 if you want. Yeah, that's fine. And then for y, what do we get? Yeah, so 1 over root 2, that's going to be sine pi over 4, and then we times by 2. Yeah, you can simplify if you want, times top and bottom by root 2. You can simplify it like that. Otherwise, just leave it like this. That's fine. Yeah. Any questions for these examples? Okay, very easy. So you just use those 4 formulas. You can go backwards between polar coordinates and Cartesian, and then Cartesian to polar. Right. Any questions before we carry on? You're all good. Okay. Next bit is a little bit more complicated, but not too much. It is Cartesian equations converted to polar equations and back and forth. So instead of converting individual points, we're going to convert a whole graph. Okay, so we're going to use the same formulas as before to go between the two. But now instead of mapping an individual point from Cartesian to polar or polar to Cartesian, we now have a graph that we're going to be converting. So let's have a look at a few examples. So let's say we have y equals x squared plus 1. So we see that this is an equation, right? Parabola. in the Cartesian coordinate system with x and y. What we want to do is convert this into the polar coordinates system with r and theta. So the x we need to transform across and the y we need to transform across. How do we do that? Well, we know how to convert x. So going from x to r and theta, what is that going to be? I've got an x there, I've got a y there, and I want this to become something with r and theta. What can I substitute? X equals something that we can use. R cos theta. Good. And y, we need to convert that as well. So that will be r sin theta. Yeah. So if we substitute that inside here, the Cartesian equation with the x's and the y's becomes a polar equation with r and theta. Is that clear? Okay, so let's see here. So y, that's going to be r sin theta. X, that's going to be r cos theta squared. Okay, because it's x squared plus 1. Yeah. We can multiply that out a little bit. So we've got r sin theta is equal to r squared cos squared theta plus 1. And now we can solve for r as a function of theta, just like we had y as a function of x. Make sense? So in the beginning, we had y as a function of x. We want to convert that to polar. So now it will be r as a function of theta after converting. So let's do that. So we'll have 0 equals r squared cos squared theta minus r sin theta plus 1. It looks like a mess, but we're only focusing on the r. You see we have r squared, r, and a constant. It's just a quadratic. So there, and there. We can just use the quadratic formula, right? We don't have to worry about the other things. So r as a function of theta, instead of y as a function of x, we have r as a function of theta, is equal to minus b plus minus root b squared minus 4ac over 2a. Just quadratic formula. And we have there a, b, and c. So we can substitute. Okay, so minus b, that's just going to be sine theta plus minus square root b squared. That's just going to be sine squared. Okay, minus 4 a is cos squared. And c is just 1. All over 2a. So that will be 2 cos squared. So instead of having the equation y as a function of x, we have a new equation, r as a function of theta. Yeah, we've converted between them. Let's look at one more, and then the last one will be for homework. So number 2. Yeah. Sorry? Yeah. Yeah, minus b, so minus sine theta is sine theta. Yeah, no, minus to get that there. Yeah. Okay, so number 2, we have x squared plus y squared equals 2x. Okay, so this is in Cartesian form. We can see that it's got x and y. We want to convert this, whatever graph this is, into polar form. So we've got x's and y's. We don't want that. We want r and theta. So we want to get rid of the x. So x will be r cos theta to substitute. And we want to get rid of the y. So that will be r sine theta. So we substitute. X is r cos theta. Y is r sine theta. Yeah. And that will convert this to polar. So x, that will be r cos theta squared. And then y, that will be r sine theta squared. And then 2x, that will be 2r cos theta. Yeah. Now we just expand out, simplify. So the first bracket there, that will be r squared cos squared. Second bracket, r squared sine squared. And then the 2r cos theta, that just stays there. Yeah. On the left-hand side, we've got r squared. That's a common factor. We can take that out. Okay, right side, we can just keep that. Okay, cos squared plus sine squared, 1. Okay, we've got r squared on the one side, r on the other. We can cancel. And we get r of theta is 2 cos theta. Yeah. So from this Cartesian form, whatever this graph is in terms of x and y, we can convert to this polar graph now with r and theta. Any questions for this one? Very simple stuff. Instead of x, you put r cos theta. Instead of y, you put r sine theta. Last one, this will be for homework. We have y equals 2 over x, where x is greater than 0. Okay, so it's just a hyperbola, but the first quadrant's part of the hyperbola. Okay, so please convert that from this Cartesian form of the hyperbola to the polar form of the hyperbola. Okay, so that's for homework. All right. Any questions about going from the Cartesian to the polar? All good. Okay, let's go the other way now. So we're going to start with the polar equation, and we're going to convert to a Cartesian equation. Okay, so going the other way, polar equation to Cartesian equation. Very simple. Let's look at example number 1. So here we have r equals 3 sine theta. Yeah, so this is in polar form, right? R is a function of theta. What we want to do is convert this back to Cartesian form. So how are we going to do that? So notice on this right side, we have sine theta, okay, by itself. That is almost y. Okay? Y is r sine theta. We're missing that. Does everyone see that? Okay, we're missing the r to make that into a y. So what we're going to do is multiply the left side and the right side by r. So we get r squared is equal to 3r sine theta. Okay. Does everyone see that? Okay. Now, on that right side, r sine theta, what does that become? Y. And on the left side, r squared, what does that become? X squared plus y squared, from that formula we had earlier. Yeah. So on the left side, r squared, we can write as x squared plus y squared. And on the right side, r sine theta, we can write as y. Yeah, pretty simple. Any questions for this one? They're all good. Okay. Number 2, fairly similar. We have r equals tan theta. Now the tan theta, that bothers us a little bit because when we're converting, we need sine theta and cos theta, right? Okay. But we got tan, but we can rewrite that as sine over cos. And we know that sine theta we can write as y, r sine theta we can write as y, and r cos theta we can write as x. But we see that's missing, right? The r is missing. But that's fine. If we multiply the top and the bottom by r, we're not doing anything to the equation, but the top becomes r sine theta, the bottom becomes r cos theta, which is what we want. So we're going to multiply by r over r, which is just multiplying by 1, so we haven't changed anything. So we have r is r sine theta over r cos theta. Yeah. And now we can convert. We know how to go back and forth now. So r, we look back at our original equation here. R there, that's root x squared plus y squared. And r sine theta is y, r cos theta is x. So we just substitute. So we end up with the Cartesian form. Okay, now you don't have to simplify further. This is fun. Okay. Any questions for this one? Okay, pretty simple. We're just substituting those equations we had earlier. Number 3, I'll leave that for you to do for homework. So this is r squared equals sec theta. Okay, again, there's a little problem. Sec, that's an issue. We want sine and cos to convert. But how can we rewrite sec? 1 over cos, good. But we're missing the r. That's fine. We can divide both sides by r. And we get r on the left, r cos theta on the right, and we can convert. Yeah. So I'll leave that for you to do for homework. Yeah. Any questions about converting from the polar to Cartesian? You're all good. Okay. The last bit for today, we won't do too much more on the sketching. We'll start a bit today and then we'll finish the rest on Thursday. Okay, so these polar equations over here, so like the r equals 3 sine theta, r is tan theta, r squared equals sec theta, we want to sketch these now. Okay, sketching polar. So it's polar equations, but you'll probably see it as polar curves in the textbook. Okay, so we want to sketch polar curves or polar equations in a similar way we did sketching for Cartesian equations. Right, so I gave you y equals x squared plus 1. You did a little sketch of that, or y equals x cubed or whatever. We're going to do the same sort of thing, but now in polar coordinates instead of Cartesian coordinates. So we'll start off with a very simple example. They do get a little bit complicated, so just follow along carefully. So number 1, r of theta is equal to sine theta for 0 less than or equal to theta less than or equal to pi. So we want to sketch this curve here. Now, we can't sketch it on the Cartesian plane because the Cartesian plane is for Cartesian coordinates. If you're given a polar equation, you need to sketch it on the polar plane for polar coordinates. So what does that look like? So we have to draw in the following. So it looks something like this. Okay. So we have radial lines going around. This will help us. You're right. Okay. This will help us identify the angle. Okay. So going from the right side, if we go counterclockwise, that means our angle is increasing. So as we go around, that will be the angle increasing. So we start at 0, and we go counterclockwise around, and we put in the angles. So 0, the next one, this might be like pi over 4, then pi over 2, and you go around like that. So on this left side here, that angle will be pi. At the bottom, that will be 3 pi over 2, right, going down. And then we go all the way back, and that will be 2 pi. You can put in more angle lines if you need. This should be fine. Okay, so that takes care of the angles going all the way around. But we also need the radius, the r. Remember what the radius was? That was the distance from the center to the point. And that goes outwards. So we're going to draw that in using circles. So it's going to look like this. And we end up with this spiderweb sort of shape, where that dot's right in the middle by the origin. That has radius 0. That's just a point at the origin. The first circle, that will have radius 1. Okay. And then the second circle going around, that will be radius 2. The third circle, radius 3, and so on. So we can put that in here. So here we can write that R1, radius 2, radius 3, radius 4, and so on. Okay, those radial lines, radial circles, they go outwards like that. So now any point in this diagram here, let's say this point over here, P, from before, instead of writing it in Cartesian form, this point P can be written in polar form now. So we need a radius and an angle. The radius is just which circle it's on. We see R0, 1, 2, 3, 4. It's on the fourth circle, so the radius is 4. What about the angle? Well, we see the angle goes around counterclockwise, and that will be pi over 4. Okay. So you see how this is designed for polar coordinates. So any point will be on a circle. That gives you the radius. And then the angle from that horizontal, that gives you the angle theta. Okay. Please get used to drawing this picture. We will be drawing it quite a lot. Okay. If you can't freehand this, I suggest you get a compass for tests and so on. Okay. But practice doing this freehand. Otherwise, you will need a compass and protractor and all of that other stuff. Any questions on this before we do the sketching? Okay, so how do we sketch such a thing? So what we want to imagine is that this angle here from 0 to pi is changing counterclockwise, going around. Okay. So we're going to start on the right side over there with that angle. And as the angle changes from 0 to pi, going counterclockwise, this radius, the distance going outwards, is going to change by sine of theta. Okay, so let's just pick some points to see what happens, and then we'll do the sketch. So at 0, okay, we're starting at 0 on that side. What will the radius be? So you substitute angle 0, the radius will be 0. So 0 radius means we start at the origin. So at angle 0, we start at the center. So we're going to end up being over there. Okay, this is where you start using your multicolors. So when theta is 0, the radius is 0. Now we're going to move counterclockwise, going around this diagram. And for each angle, we're going to be looking at whatever the radius will be. So let's look at pi over 4 over here. So here's pi over 4. What will the radius be when theta is pi over 4? One over root 2. So let's put here, when the angle is pi over 4, the radius is 1 over root 2. Now for sketching, we don't need the exact 1 over root 2. We can approximate it roughly. So as a decimal, what will that be? What do we get? 0.71. So 0.71, slightly less than that 1 that we have here. So at pi over 4, we're along this angle here. And we know that the distance from the origin is 0.71. So somewhere close to that r equals 1. Somewhere over there. And now we're going to move the angle even more. So we looked at pi over 4. Now we're going to look at pi over 2. So when theta is pi over 2, what will the radius be? One. Good. So now we get another color. And we put our dots over there. You can see as we're moving from the that side over there with 0, we're moving all the way around to this left side, and we're putting in the dots for every angle as we go along. Okay. Next angle, what is that going to be after pi over 2? This angle over there on the left side. What angle is that? So pi over 2 plus another pi over 4. Okay, good. So if we have that angle, what will the radius be for that line over there? Okay, so you substitute the angle, what will the radius be? Sorry? Yeah, it's the same one we got for pi over 4. Good, so let's pick a different color for that now. Let's do dark blue here. So it's going to be slightly less than 1 over there. Yeah. You see we're starting to put all these dots going around. And finally, let's put pi. So when theta is pi, what will the radius be? Will be 0. So we go back to the origin. So if we have a look at what we did, we started at the origin, and as the angle increased, the radius increased to 1. We see that it went up to 1. And then the radius got smaller, back to 0. Does everyone see that? Yeah, so we can connect the dots here. So we did something like that. We'll draw it a little bit better than this in a moment, but just to get the idea, as we went from angle 0 to angle pi over 2, the radius increased. You see the dots went further out. And then from pi over 2 to pi, the radius decreased. The dots went to the origin. And we got the shape here. Okay, so that's just doing it in terms of dots. Please don't do that for the test. You'll take way too long. We're going to look at another method, but the idea is the same. So you look at all the dots for the angles from 0 to pi. You look at what the radius is, and you put the dots. And then we connect all the dots together. So let's look at a slightly better method, or slightly faster, I should say. Okay, so this r is a function of theta. We're going to do a little bit of a side diagram, and we're going to use that to draw in our picture. So we're going to draw the following. So here we have r and theta. Okay, this is just some side working. Okay, so we've got r and theta. We know r is sine theta from 0 to pi. So it's going to look like this. Okay. Now we're going to look at where this graph here is 0, where it's increasing, where it's decreasing, and the turning points. Right, the stuff from last year. So we see that this graph is 0 at 0 and at pi. Okay, so keep that in mind. It's going to be increasing from 0 to pi over 2. Okay, it's going to be increasing. And then it's going to be decreasing from pi over 2 to pi. Okay, so you keep in track. Okay, where it's 0, where it's increasing, where it's decreasing. And lastly, we have a turning point there at pi over 2. Okay, so just keep that in mind. So it's increasing, turning point, decreasing. So this is our side diagram we're going to do to make the sketch much quicker. Okay, so we set up the same picture as before. Okay, something like that. I'm not going to put in the circles. It's going to make it look a bit too messy, but you can put in the circles if you want. Let's put some of the angles in. So you've got 0, pi over 2, pi. Right. We don't need to go further because we know we're only doing this from 0 to pi. Now, what we're going to do is instead of putting in individual points for the angles, we're going to freehand it based on our little diagram there. And whether it's increasing, decreasing, or there's a turning point. Okay. So between 0 and pi over 2, what is happening to our radial line? We see it increasing to 1. So we start at 0, and at pi over 2, it has increased to 1. So what does that look like? So it starts, so it starts at 0 here. Now you kind of need to imagine, as we're drawing this line, that the angle is increasing from 0 to pi over 2. So we start at 0, and as the angle increases, it does that. Okay, so again, you need to imagine two things at once here. So the angle is increasing from 0 to pi over 2, counterclockwise. And as the angle increases from 0 to pi over 2, the radial line increases from 0 to 1. Okay, so it looks something like this. If you imagine the... can you see that in the back? Yeah. Okay. So we start at 0 and we're increasing the angle from 0 to pi over 2. From there to there. So at this angle, the radius was 0. So we start here. Let's look at this angle at pi over 4. The radius was 0.71 something. So we're over there. And when the angle was pi over 2, the radius was 1. So we're up there. You see that? So here, the radius was 0, so we're here. As you increase it, the radius increases outwards. That increasing, and finally at pi over 2, it increases to 1. Okay, so please have that mental picture. So again, as the angle increases, we're doing the following. We're going there, then there, then there, and finally there. Okay, so these pink lines, those are the radial lines for each angle. So at 0, it was 0. At pi over 4, it was 0.71. And the radial line, or the length of the pink line, increases up to pi over 2. Increases. Now, let's go from pi over 2 to pi. So we're going counterclockwise again. What's happening to the radius? From pi over 2 to pi, it's decreasing. So we're going to start off with the radius being at 1. And as the angle increases counterclockwise, the radius must go to 0. So we can go back to the picture here. So we're going to start out here. Angle pi over 2, we start over there. As we increase the radius, like this, as we increase the angle, the radius must get smaller. Okay? So we start out at the maximum, at the turning point. As we increase the angle, follow the finger there, as we increase the angle, the radius decreases. Okay? And eventually goes to 0. So let's put that in a different color here. So it's going to look something like that. And we can put that in green. So for each angle we pick, we see that this green line is getting smaller and smaller. Okay. Going again counterclockwise, and then we go back to the origin there. Now, to help you with the sketching, please make heavy use of Desmos. You know, we used that quite a bit before. Okay, so everyone knows Desmos, right? You've used it before. So you go on here, you click the little wrench thing over here, graph settings. And over here, you'll see some options here. This first option that's highlighted, that's Cartesian. You see, it's got the X and the Y lines. The second option here is polar. You can click that, and it now goes to polar form. Okay, which is what we need. And then over here, you can put r of theta equals sine of theta, and it will draw in exactly what we had. Okay. And then over here, you can change the angle. So there's pi over 4, there's pi over 2, and all the way to pi. Here we go all the way around. Okay. So quickly, homework problem, and then we can go. Please make use of this Desmos for your homework and your tutorials. Okay, otherwise you're going to be quite lost. So for homework, r equals 3 sine theta from 0 to pi. Okay, so try that out for homework, and then we will continue on Thursday.
Hold them up just 1 minute.
Sure. Sorry, just before you go, your new SI leader just has a few things to say.